Hello everyone, welcome to another video from Biology. In this video, I'm going to talk about a human-inspired reading agent with guessed memory of very long context. This paper is published by Google Research and Google DeepMind on 15 February 2024. So basically, the problem is when we have a very long context and we want to retrieve some information, one of the way is to chunk the information, then pass those chunks for embedding, and then when we want to retrieve, we use those embedding for retrieving the information that we want. That's one of the way that usually people use for a very, very long context. This paper is a little bit different. It's talking about when we have a very long document, basically, like a book or maybe a chapter, or maybe that's a data sheet or something that's very long, and you can still use RAG with all of that uh, like pipeline, but there are some other ways to getting that, and also if you're doing that, you don't need to even have an embedding, um, and all of the like whole pipeline would be much simpler. Also, you will get a little bit improvement. I will talk about that. They have designed a method like a pipeline to decide what content to store together in a memory episode, and then compress those memory episodes into short episodic memories called gist memories, and then take action to look up passage in the original text if ReadAgent need to remind itself to relevant details to complete the task. Basically, we have three steps. One is we ask the LLM to give us some episode. So it's called the memory episode. So we ask LLM by passing some pages, and we ask it like in what place do you think that we need to have a pause, and then we get those pause points. Also, there is a word limit based on that, and then on each episode, we call it episode, we ask LLM to summarize it, but not summarizing. They're mentioning something about like word summarize into the LLM was degrading the performance, so they use some word like shortening. So they short the episode and convert it to the gist. And now they have a gist which is much compressed comparing to the very long context. And then on that gist, they have some sort of like loop that they will ask, like, can you get the information from this gist? Like by just passing all of the some of the gists, so the LLM can say, like, I need this page because each gist also has some reference to the original page. So there are two read agents. I will talk about that. And you can see the diagram here. So we can have a very long text, and we convert them to the episode pagination. So we have multiple pages. Then from them we get gist, like page one gist, page two gist, and then we have LLM that read this one, and sometimes, if needed, some of these pages. They're mentioning something interesting here. They said that fuzzy trace theory points that people from two types of memory representation about the past event: verbatim and gist memories. Gist memory often episodic or fuzzy memories of past event, whereas verbatim memories contain details of past event. People refer to reason with gist rather than with verbatim memories. So I think that's the like philosophy behind why they choose this algorithm. So I have highlighted some part that is worth to read. They're mentioning here the three steps that we talked: episodic pagination, where we prompt LLM to decide where to pause in the reading text, and the content between pause point become an episode, which we refer to as a page in this work. And then we have memory gisting, and where we prompt the LLM to compress each page into a shorter gist and associate the gist with the corresponding context. This gives the episodic gist memory. And then interactive lookup, where the LLM looks at the given task and the complete set of gists in context, makes decision on what page to look up, combine the gist with these raw pages, and then solve the task. So the point here is we are not answering the final question just based on gist, because they're mentioning that by summarizing or even shortening, we are losing some of the details that we need. But this gist can help us, like which part of the text we were looking for, and then we can again go back to those pages, those parts, and then pass them to the LLM. Very similar to the embedding, but this is different because it's very similar to like uh, React or chain of thought, that we have some sort of clue that this can be the solution, then we have to go and retrieve that, something like that. The LLM performance tends to decline with increasingly long inputs, even when they don't exceed the specified context length. There is a paper called Lost in the Middle, How Language Model Use Long Context. And they're showing here in this paper that like the position that if you have a long context, the position that usually we can get a good answer or good accuracy is in the start or at the end. But in the middle, we are lost. So that's why it's called Lost in the Middle. This is a cool paper also. So they are referring to that. Another thing is that LLM performance also shown to be sensitive to distracting information in the context. So when we use, for example, RAG, maybe the embedding get distracted, like the embedding that we are retrieving, like 5 top embedding that we are getting is referring to some distracting information. And if we go down, they are showing their prompts. So building gist memory has two steps: pagination memory and gisting. This is for pagination. So first they ask the LLM that give me the point that I need to pause, so create a page. So it said you are giving a passage that is taken from a large text and some numbered labels between the paragraph in the passage. Numbered labels are in angle bracket. For example, if the label number is 19, it showed 19 in the text. So they are referencing like each paragraph, for example, that this is one paragraph. And when language model want to return the result, 57 is a good point to break, answer with breakpoint 57 because of this reason. Okay, so it's somehow like have a small summary about that, like why we need to break this way. And then from this, they will get pages. So they do just some like applying some maybe regular expression on the result, stuff like that. And then they ask another question. Please shorten the following passage. Just give me a shortened version. Do not explain your reason. And then we have the page tag. We use the word shorten in the prompt to generate this summarizing gist, as it tends to help preserve the narrative flow, making it more natural to concatenate. And use summarize tended to produce a restructured summary in our experiment, which is interesting. And then they mentioning ReadAgent P and ReadAgent S. And ReadAgent P in parallel, looking to all the pages and sequentially looking up one page at a time for ReadAgent S. So ReadAgent P prompt is something like that. So let's read this. So the following text is what you remember from reading an article and a multiple choice question related to it. You may read 1 to 5 pages of the article again to refresh your memory to prepare yourself for the question. Please respond with the pages you would like to read. For example, if you only need to read page 8, respond with I want to look up page 8 to do something. If you would like to read page 7 and 12, respond with I want to look up page 7, 12 to read something. If you want, and another example, just to put them in the bracket so they can retrieve those pages for the next prompt. Do not select more pages if you don't need to. You don't need to answer the question yet. And they have text with some gist memory and the question. So they just, this is just like the gist memory, all of the gist memory that we have, and pass it to the LLM, and LLM said, oh, seems like gist memory number 410 has some solution in it. So they just need to explain that. And then ReadAgent S has something like this. The following text is what you remember from reading a meeting transcript followed by a question about the transcript. You may read multiple pages of a transcript again to refresh your memory and prepare to answer the question. Each page that you reread can significantly improve your chance of answering the question correctly. Please specify a single page you would like to read again, or say stop to read the page again. Respond with the page number, replacing page number with the target page number. You can only specify a single page in your response at a time. To stop, simply say stop. So you see that they have gist within line expanded page. So they have gist of that page plus expanded that page. And they said, please read. Do not ask to read them again. List of pages number already read. They are showing like what will happen if we use agent P or if we use agent S. So there are two ways of retrieval. At the end, they're showing like if you have 6 pages in information, it can increase like 3.5 of the original words. In terms of price, how much would be larger? It's like 3.5. And for rating, they have LLM rater. So have another LLM and they are asking it, so this was the question and this was the model reason text. And this is a reference response text. So now just give me, so there are two prompts. One is permissive and another one is strict. So permissive is saying, just give me yes, yes partially or no. And another one is very similar, but it's just saying yes or no. And for LLM rater, they say if these two, one of them saying yes, we accept it as yes. If this model say no, but it say yes partially, we accept it again as yes, as a partially correct. And if both of them say no, we say, okay, this is not right. So that is the way that they are calculating the performance. So for comparison, this is interesting. So they have, first of all, BM25 retrieval. Then we have the neural retrieval with embedding using Gemini API. Another one is full raw content. So also this is compression ratio. So how much we compress the text to get the information. So for full raw, you see there is no compression. And for full raw, for like 6 pages, because maybe Gemini can get those long contexts, we get 84% accuracy, which is, 85% accuracy, which is very good. And on BM25, which is, I think, very good in terms of we don't need any embedding database, stuff like that. It can work in par with the embedding. So you see like in embedding, maybe in top 4, we can get 84, but it's very similar, like 84 also with BM25. Maybe compression ratio is a little low, but in terms of cost, I think this one is much better. Then we go to the gist memory. So if you just use gist memory and pass those gist memory, like summarize information, and then ask LLM to answer just based on the summarization, we get this accuracy, which is below when we use RAG. In terms of comparison, it's much better, but in terms of what we can get out of it, it's not that good. So that's when we have the ReadAgent. So this P is the agent that's returning all pages together. I only need page 1 for retrieval. So it, based on the gist, it could get to the page 1. So the amount of data we use for answering the question is just a little less. And this is not like 1/6 because we already have gist and all of that. So we have 83% here. Yeah, that makes sense because when we have like 6 pages and then we have them paginated, maybe on some pages, this is a real page, yeah. On some pages, we get some portion of that to get the answer. But overall, the point is when we compare this accuracy, for example, with embedding, which is this one is better about 2%. Also with BM25, it's like 2% better. If we compare this one, we see 59% accuracy or 60 versus 55% and 53% on embedding and BM25, which is this one is much better. And one of the things they're mentioning is like look at this table again, and you see like when we have 6 pages, number of distraction can be increased. So sometimes it's better to not look at all of the pages. One other thing they mentioned here is if you have ReadAgent versus gist memory plus embedding. So we summarize it, then we embed it, and then from those we get the information. They mentioned that this is equivalent to replacing ReadAgent prompt-based retrieval with neural retrieval embedding. And ReadAgent retrieval perform better here. So they are mentioning here, even if we summarize it, then on summarization, we apply embedding. Maybe it's not performing well as when we have ReadAgent P that give us all of the pages, and then we look into them. Yeah, that's it. I think we learned something from this paper. Have a great day.